Hello everybody. Today's topic is reference electrodes. Myself Dr. Dignavarkis. Reference electrodes. It is impossible to determine the absolute value of a single electrode potential because a half cell cannot function by itself. Electrodes with unknown potential can be coupled with other electrode whose conventional potential value is known. Difference in potentials between these two electrodes can be measured and we will get the single electrode potential of a half cell. We have discussed this earlier in our video class named electrode potential. Okay, so reference electrode is that electrode whose conventional potential value is accurately known. Reference electrode is that electrode whose conventional potential value is accurately known so that we can couple this electrode with other electrode whose potential is unknown to us, and we measure the difference in potentials between these two electrodes and we will get the single electrode potential of a half cell. Examples for reference electrodes: we know normal hydrogen electrode or NHE, standard hydrogen electrode or SHE. That is an example of reference electrode. The representation of the hydrogen electrode, that is platinum wire, which is coupled with a platinized platinum foil, which is kept in 1 molar HCl solution. The hydrogen gas is bubbled throughout at 1 atmospheric pressure. This is the normal hydrogen electrode or standard hydrogen electrode setup. So the cell representation is platinum, hydrogen in the gaseous form at 1 atmospheric pressure, H plus, aqueous, 1 molar concentration, that is 1 molar concentration of HCl. It is arbitrarily the potential value of 0 volt at all temperature. Normal hydrogen electrode gives the potential value of 0 volt at all temperature. The cell reaction is like that: 2H plus 2 electron giving H2 gas. Standard hydrogen electrode or normal hydrogen electrode is the primary reference electrode. It is known as primary reference electrode because SHE is not a very convenient for routine work because of the necessity of bubbling hydrogen gas at 1 atmospheric pressure over the platinum electrode. It is a tedious job, so it is considered as a primary reference electrode. Hence, several other electrodes have been devised and their potentials determined accurately relative to standard hydrogen electrode so that they can conveniently be used for the determination of unknown electrode potential. Such type of electrodes are known as secondary electrodes that we will discuss later. Measurement of single electrode potential. We know it is impossible to measure experimentally the absolute value of a single electrode potential because a half cell cannot function by itself. Hence, what is possible to determine the potential of an electrode related to a reference electrode whose potential is arbitrarily fixed. Here we are using a reference electrode as normal hydrogen electrode or standard hydrogen electrode. The normal hydrogen electrode, which is coupled with the electrode under consideration, through a salt bridge to form a complete galvanic cell like this. If we have to measure the zinc electrode potential, we couple the zinc in zinc sulfate solution, that is a half cell, with a reference electrode. Here it is a standard hydrogen electrode or a normal hydrogen electrode by a salt bridge, and we can measure the electrode potential of the zinc electrode. Okay. The difference in the potential between the two cells, here the zinc cell electrode and the hydrogen electrode, using a potentiometer. Here you can see the figure of potentiometer that are common in all MSc lab. And potential of standard hydrogen electrode is arbitrarily fixed as 0. Okay. So measured potential difference is numerically equal to the potential of the electrode under consideration. Here, if we are measuring the electrode potential, its standard hydrogen electrode potential is 0, and we get the potential of zinc electrode. For other reference electrodes, here you can see a secondary or subsidiary reference electrode. The electrodes whose potential determined accurately relative to standard hydrogen electrode, so that they can be conveniently be used for determination of unknown electrode potentials. We know standard hydrogen electrode is not very convenient for our routine work because of the necessity of bubbling hydrogen at a uniform pressure of 1 atmosphere over the platinum electrode. Secondary reference electrodes are electrodes of the second kind, that is, metal electrodes coupled to a solubility equilibrium of a salt of this metal and an electrolyte solution containing a fixed concentration of the anion of the sparingly soluble metal salt. Examples for the secondary electrode is silver chloride electrode, that is silver chloride chloride 1 molar solution. And the other one is Columnal electrode, whose cell representation is mercury liquid, mercurous chloride, and chloride in aqueous. Silver chloride electrode, whose standard electrode potential is about 0.2224 volt, and for Columnal electrode, according to the concentration of the potassium chloride, here its value is different, and it is about 0.2 to 0.3 volt range. Columnal electrode. Columnal electrode, which belongs to the category of metal insoluble metal salt electrodes. Columnal electrode is a reversible electrode. It consists of a mercury in contact with mercurous chloride solid, that is columnal, and aqueous potassium chloride solution. The cell representation is like this: mercury in contact with mercurous chloride, that is columnal solid, and aqueous chloride solution. In other way, mercury liquid in contact with mercurous chloride, that is columnal in solid, and potassium chloride solution, aqueous solution. Columnal electrodes potential depends upon the concentration of potassium chloride solution used. There are 3 different concentrations of potassium chloride that you can see in the table given here. There are 3 types of concentrations: 0.1 normal concentration, 1 normal concentration, and saturated solution of potassium chloride. So based on this concentration of potassium chloride solution, there are three types of Columnal electrodes. First one is decinormal Columnal electrode, that is 0.1 normal potassium chloride solution is used here, and its electrode potential is 0.3338 volt. Second one is normal Columnal electrode, that is NCE, in which the potassium chloride solution is 1 normal concentration. Its electrode potential is 0.2800 volt. The third one is SCE, that is saturated Columnal electrode, in which potassium chloride solution is in the form of a saturated solution, and its electrode potential value is 0.2415 volt. So Columnal electrode is liquid mercury in contact with mercurous chloride, that is Columnal in solid state, and potassium chloride aqueous solution. Depending upon the concentration of the potassium chloride used, if it is zero point 0.1 normal, it is decinormal Columnal electrode. 1 normal concentration of potassium chloride used here, then it is known as NCA. So if it is a saturated solution of potassium chloride, then Columnal electrode known as SCE. And for each of the concentration, the potential difference or electrode potential is given here. It is different. Construction of Columnal electrode. We know Columnal electrode is a cell which contains liquid mercury in contact with Columnal, that is mercurous chloride in solid state, and aqueous potassium chloride solution. Here you can see a general design of Columnal electrode. In this, there is a glass tube. It has a side tube, two side tubes. One is S1 and other one is S2. And the glass tube filled with potassium chloride solution. And here at the bottom of the glass tube, there is pure mercury, which is pasted in contact with a paste of Columnal and pure mercury. And inside glass tube, there is a thin glass tube is placed, to which the platinum wire is sealed, which is in contact with mercury, and at the bottom serves to make the electrical contact with the external circuit. Okay, I repeat, this is a glass tube, and here two side tubes S1 and S2. At the bottom of the glass tube, there is mercury is filled here, and the mercury is covered with a paste of Columnal and pure mercury, that is given in this part. The tube is filled with the potassium chloride solution. Its concentration is different. If it is a 0.1 normal potassium chloride solution is filled in the glass tube, then this Columnal electrode is known as decinormal Columnal electrode. If the concentration of the potassium chloride is 1 normal, then it is known as normal Columnal electrode. If it is the glass tube is filled with a saturated solution of potassium chloride solution, then the Columnal electrode is known as saturated Columnal electrode, SCE. Okay. So the potassium chloride solution entering into the tube through S1 side tube. It is also filled in the S2 side tube and covered side here ending in a jet. It is through the side tube the Columnal electrode is coupled with any other electrode whose potential is unknown, and by coupling this unknown potential electrode with this columnal electrode whose potential is known according to the potassium chloride, which according to the concentration of the potassium chloride solution whose potential is known, and by coupling these two electrodes we can measure the potential of the unknown electrode. Okay, so here a platinum wire is used, or which is sealed in a thin glass tube inside the glass jar, and this platinum wire is in contact with the pure mercury, and this platinum wire is sealed in a thin glass tube, and the glass tube containing a little mercury at the bottom serves to make the electrical contact with the external circuit. So this is the construction of columnal electrode. So we can construct columnal electrode in this way. Okay. So the cell reaction is like this. Columnal mercurous chloride plus 2 electron give mercury and chloride. This is the cell reaction. Example of secondary reference electrode is silver chloride electrode. It is also come under the category of metal insoluble metal salt electrodes. So the representation of the electrode is silver in solid in contact with silver chloride in solid and aqueous chloride solution. The reaction is silver chloride plus electron giving silver solid and aqueous chlorides. The electrode potential value of this secondary reference electrode is 0.2224 volt. So we can couple with any other electrode whose potential has to be determined. Conditions. In most electrochemical measurements, it is necessary to keep one of the electrodes in an electrochemical cell at a constant potential. This so-called reference electrode allows the control of the potential of a working electrode or the measurement of an indicator electrode. The standard hydrogen electrode plays the role of a basic reference element in electrochemical devices. However, in practice, it is difficult to handle. Therefore, a secondary reference electrode or subsidiary reference electrode are preferred in most experiments. What are the conditions the secondary reference electrode must fulfill? First one is it should be chemically and electrochemically reversible. That is, its potential is governed by the Nernst equation and does not change in time. Second condition is that the potential must remain almost constant when a small current passes through the electrode and reverse to its original value after such small current flow. That is a non-polarizable electrode. And the third one is the thermal coefficient of potential should be small. By this, I conclude here. Thank you for your attention.